reduce the rotational speed like before, 2 rounds per second. Okay, and I will change this to a galvanometer again. Yeah, you see the needle oscillating back and forth with a relatively small amplitude, and the frequency, the speed of this needle oscillating is also pretty slow. The frequency is low, right?
Yes.
The red dot, the electrons oscillate back and forth, but not very fast. With the frequency, the speed of rotation here is 2. But when increasing the speed to like 6, like here, you see, the needle oscillates faster with greater amplitude, meaning the amplitude of the current, the maximum current also increases, then the frequency of the current increases as well. And we can visualize that with this oscilloscope again with the speed up to like 2 rounds per second. Okay, you see this is a graph of the current. The distance, note the distance between the peaks, okay, and also the amplitude, how high the peak is. And now I will slowly increase to 3, see? And now to 4. You see what happened? To 5. The peak get higher and also closer to each other, meaning the current not only increases in magnitude, but also increases in frequency. Okay?
Okay.
The increase of the magnitude, the height of the peak, is explained by Faraday's law. Okay, again, Faraday's law. The rate of the change in magnetic flux, meaning it is proportional to how fast we rotate a coil, directly relate to the EMF, electromotive force, and also the frequency. Yeah, it is a quite difficult question, but if we can do that, it means we deeply understand the problem about induction. There are many mistakes in the first questions. From 1 to 5, you made many mistakes. So we have to look back and see why. Such as question 2. Let's go back to question 2, huh?
Okay.
4 different masses, balls, 4, 3, 2, 1 kilogram, not from different heights. 1, 2, 3, 4 meters from the ground. The statement about the balls is correct. You chose A. The ball P has the greatest acceleration. If the mass of the balls is small enough, then the acceleration is the same, which is the free fall acceleration, 9.8 meter per second square. So the acceleration are supposed to be the same, not different from different balls. The reason the acceleration is the same is because the acceleration is the force, which is the mass multiplied with the acceleration and divide the mass. Newton's second law, okay? The acceleration A is mg, which is the weight, divided by the mass. So that is equal to g, 9.8. So the answer A is not correct, okay? The correct answer is D. The ball S has the greatest average speed because average speed is the distance over time. You will use the equation, the distance equal ut plus 1/2 at squared. Remember this equation?
Yeah.
U is 0. Drop from rest, meaning the initial velocity is 0. Okay, and then add it with at. A is g, 9.8, and the time t squared. And therefore, the time is determined by 2 times of the distance divided by 9.8. This is the time. So the time is proportional to the square root of the distance. The average speed is the distance over the time. Okay, so taking this time into this equation, the time is here, 2 times of the distance over 9.8. Okay, and the distance at the top here. So we can simplify that, huh? D at the top divide the square root D at the bottom, it results in D square root at the top. Okay,
Yeah.
and at the bottom is 2 over 9.8. So according to this equation, this is the average speed, huh? Average speed. According to this equation, the average speed is greatest for the ball with the highest height, which it dropped, which means this ball 4 meters. Okay, the ball S has the greatest average speed. I'm thinking of like a simpler way to explain this. Okay, there's a simpler way like this. Because a ball dropped from a lower height, such as this one, very low. So the time it flies down and reaches the ground is the minimum time, right? And the ball here has the maximum time of falling, right? It has more time to fly, and therefore it will increase, it will gain more speed. It gain more speed, and therefore the average speed is greatest. Okay, because the acceleration is 9.8, the same value for all the balls, and therefore more time of flight will make the speed faster, and average speed, which is average speed is a distance over time. Okay, will be greater. This is a pretty difficult question, so I hope that you understand this explanation.
Yeah.
More time to fly, okay, and more time to gain, to increase the speed, getting more speed. Question 3, you answer also incorrectly. Object traveling in straight line, the diagram in the speed time graph for the object, at which label point is the object accelerating at greatest change? Okay. The question is the acceleration, accelerating greatest rate. This the change of velocity, it means the acceleration. And acceleration is determined on this graph of the speed, on the speed versus time graph. Okay, acceleration is the gradient of the graph, is the slope of the graph of the speed versus time graph. Okay, and therefore the part D here, it has the highest slope. You see, the slope is so high, and therefore it has highest acceleration. Now keep doing this question, this paper. Question 4, which statement about the masses and weights of an objects on the Earth is correct? Your answer, heavy objects always have more mass than light ones. It seems to be correct. Statement about the mass and the weight, a balance can only use to compare weights, not masses. Masses and weight. Okay, A is also correct, but B seems like correct. But the reason why B is wrong, heavy objects always have more. Okay, so the word heavy means the weight, not the mass. Okay, we have to understand that the heavy here means the weight. The weight greater doesn't mean that the object have more mass, because if we do measuring the weight at different planets, the weight of an object like 3 kilograms on Earth can be greater than the weight of the object 5 kilograms on Mars or on the moon. so B is wrong because of the word heavy means the weight, and the answer correct answer is A. Okay, the weight is the attraction of the Earth calculated by the mass of the object multiplied with the gravitational intensity of the Earth gravitational field. On Earth, that is 9.8, but on Mars, it's about 2/3 of that. the way on different planets are different. So question 4 here is also a confusing and likely to be wrong for many students. Okay, question 5. An object in space propped above the Earth weighs 3.5 newtons. The gravitational field strength at the height of the space prop is 7 Newton per kilogram. The gravitational field strength on the Earth's surface is 10 Newton per kilogram. What are the mass and the weight of the object at the Earth's surface? The mass on the Earth's surface is the same as the mass on the prop. You get the weight here, 3.5, and then divide the field strength on that prop. The space prop has 7, so the mass is 0.5 kilogram. Okay. You have to take the weight and divide the field strength at where it is calculated the weight, meaning on the space prop. Okay, space prop, and then the weight on Earth. The weight on Earth is 0.5 kilogram multiplied with 10, which is 5 newtons. Okay, but according to mass scheme, it is A, and A is not 5 newtons. Where the mass scheme? I like accidentally close it. Okay, here. For question 5, the answer is A. The weight on the Earth's surface, no way. Okay, I think that is the wrong mass scheme. The weight on the Earth's surface must be greater than on the prop, because the field strength on Earth's surface is 10, not 7, greater than 7. Okay. So did you choose B? You just roll the W equal mg, huh?
Yeah.
Okay. This is a general physics topic very long time ago, like the beginning of the course last year. So yeah. So I see your weakness. You need to focus on this part. Mechanics, general physics. Question 6. A skydiver jumps from a stationary helicopter and reaches a steady vertical speed. It is the terminal speed. Then opens her parachute. This statement about the falling skydiver is correct. You chose D. When she falls steady speed, air resistance is 0. No. The air resistance always different from 0 and increases with the speed she falls. The speed here, she falls when jumping out of the airplane, will vary like this, huh? Increase and increase, and then opening the parachute, the speed decreases suddenly, and then slowly decrease due to after opening the parachute. Okay, like this. Here the point when she suddenly opened the parachute. Suddenly drop, not this much, but kind of sudden drop when opening the parachute. Okay. This is time. Okay, that is speed. The air resistance force will vary like this. Air resistance. It increases from a certain value, not from 0. Okay, from F0, increase it with the speed, and then suddenly increase even more, meaning at a higher rate, because when the parachute is open, I'm trying to make it like steeper, greater, much greater, much more when the parachute is open, huh?
Yeah.
Therefore, it is not 0. When she accelerates, the resultant force on her is 0. Steady speed when she accelerates, the resultant force on her is 0. Answer C in the mass scheme already wrong. Finding the mass scheme again. Where is it? Yeah. Question 6, answer C. It is not C, definitely. Is this the right answer? March So 2020, wait. No. 2022. Okay. I need to open the paper 2017 instead. This paper is in February, March 2017. Yeah. That's where I cannot open it. No scheme. Question 6, answer A. Okay. As apparatus opens, acceleration is upwards. Okay, definitely. Because when the apparatus is open, the air resistance is a lot greater than the weight, and it will make her speed slow down. Okay, so the acceleration is upward in the same direction with the air resistance.
Okay.
We didn't review this topic since we began studying together, huh? Yeah, this is the first topic, general physics, long time ago. This is a link to the mark scheme, so that next time I will put the link in the Kakaotalk, huh? So that if you have time, keep doing this paper.
Okay.
Yeah. Wait. I saved the file in the wrong place. Update that. Okay, let's do a final question 7 here, and 9. Okay, and 8. A car moved in a circular path. It turned a corner on a horizontal roll. The car moves at constant speed. The description of the forces acting the car is correct. The forces are unbalanced. Yes, it is unbalanced, and the resultant force act on towards the center. I think this time, this question you answered correctly. 7, yes, C. And that force pointing toward the center is called centripetal force. Centripetal force, okay? FC, centripetal force, which is unbalanced, different from 0. Okay. Question 9, 8. A moving body undergoes a change of momentum. What's the unit of change momentum? Momentum is mass multiplied with velocity, and therefore its unit is kilogram meter per second. But it also has an equivalent unit, which is Newton times second, not divide second. Okay, the answer is this one. The reason for this unit is that here momentum, mass times velocity, kilogram meter per second, Newton. Newton is the force. Okay, normally we can start from this one, the Newton's second law, F equal ma, huh?
Yeah.
A is the final velocity, subtract initial velocity, and then over the time. And then multiply both sides of the equation with the time. F multiplied with time equal mv minus mu. Okay, is that correct expression? This mv minus mu is the change of momentum. And this product, F times t, is called the impulse. And the unit of this one, F times t, is Newton multiplied with second, and therefore the unit here of momentum change, which is kilogram meter per second, is also equivalent with Newton times second. Okay, Newton times second. Probably students memorize the unit Newton times second, but not many students, like 60% and 40% forgot that. Okay, so we'll keep doing that this question next time. Or if you have like some time and you want to improve, review this topic, you can do it yourself, and check the answer. See you later on the next Wednesday.
Bye.
Mhm.